Hello everyone, in this video we are going to have a look at question number 16 to question number 22 of quant section of CAT 2008. So let's start with question number 16. Question says Rahim plans to drive from city A to station C at 70 km per hour to catch a train arriving there from B. He must reach C at least 15 minutes before the arrival of train. The train leaves B, which is located 500 km south of A. So let's have a look at it. 500 km south of A. Let's say city A is here and city B is going to be over here, south of A, and the distance is going to be 500 kilometers. And after that, C is located between west and northwest of B. Between west and northwest of B with 60 degree to AB. So it is going to be like this, 60 degree to AB. This is city C, which is in which direction? In between west and northwest. And this angle is going to be 60 degrees. After that, also C is located between south and southwest of city A. Correct. Yes, the diagram is correct. The diagram is going to be like this, and AC and AB, the angle between AC and AB is 30 degree. It means this angle becomes 90 degree. So it is a right angle triangle. So in this right angle triangle, hypotenuse is 500, so side opposite to 30 degree becomes half, that is 250 kilometers, and side opposite to 60 degree will become root 3 by 2 into hypotenuse, that is 250 into root 3. Now after that, let's read the remaining part of question, or let's read the question again. Now we done with the location of city A, B and C and the distances between these cities. After that, Rahim plans to drive from city A to city C. So basically Rahim is over here. Rahim is supposed to travel in this direction with a speed 70 km per hour. After that, to catch a train arriving there from city B. It means train is going to travel in this direction, city B to city C. Train starts at 8 o'clock with a speed 50 km per hour. It means train will be over here after 5 hours. 250 divided by 50 after 5 hours, that is 5 hours after 8 o'clock. It means 1 o'clock. Train will be at city C. So over here, how much time Rahim requires to travel 250 root 3 distance with a speed 70 km per hour. Let's find that. Time is equal to distance is 250 into root 3, approximately 1.7 divided by 1.73. Let's take 1.73 divided by the speed is 70. So let's solve this further. This is going to be how much? 173 divided by 4 into 7. So let's solve this further. So this is going to be 4 4s are 4 3s are 0.25 divided by 7, and this is equal to 6 point how much? Let's have a look at it. 6.71 are 7, the remainder is 5, 7 7s are 49, 6.17 hours. It means 6 hours and 0.17 into 60, 1.7 into 6, that is around 10 minutes. So Rahim requires 6 hours 10 minutes to travel this 250 root 3 distance. It means, and it is also given that he should reach at least 15 minutes before the arrival of train, means plus 15. That is equal to 6 hours 25 minutes before he should start. So our answer is going to be 6 hours 25 minutes before 1 p.m. he should reach the station C. Let's have a look at, let's calculate this. So let's go 6 hours behind. If you go 6 hours behind, it is 7 o'clock. From 7 o'clock, let's go 25 minutes behind. It is going to be 6:35. So he should depart, he should leave city A somewhere around 6:35. So the closest option is 6:30. We should mark over here. After this, question number 17. 3 consecutive positive integers are raised to first, second and third powers respectively and then added. The sum obtained is a perfect square whose square root is equal to the total of the 3 original integers. Which of the following best describes the minimum, say m, of these 3 integers? Let's the minimum integer is m. So the next becomes m plus 1 and the next becomes m plus 2. So the first number to the power 1, then second number to the power 2 and then third number to the power 3. This addition is going to be perfect square. This addition is going to be perfect square whose square root is equal to sum total of the original 3 numbers. The original 3 numbers are m, m plus 1 and m plus 2. It means this total is going to be 3m plus 3 bracket square. So let's solve and we need to find the minimum possible value of m. Let's have a look at it. We need to find which condition m should satisfy out of these 5 options. So let's expand this. This is going to be m, this is going to be m square plus 2m plus 1. Now m plus 2 bracket cube is m cube plus 8 plus 3 to the 6m square plus 6 3 to the 6m square, then 3 4 the 12m is equal to, this is going to be how much, 9m square plus 9 plus 18m. So let's solve this further. So this m cube is going to be as it is over here. So this 6m square plus 1, that is 7m square, minus 9m square, that is minus 2m square. After that, 12m plus 2m is 14m, minus 18m is minus 4m. Now, after that, what is remaining? This minus 4m plus m, that is equal to 3m, minus 3m. So this is going to be minus 3m. After that, this plus 1 and plus 8, 9 and 9 gets cancelled out, is equal to 0. So now what we are going to do is, let's divide this equation by m, because m cannot be 0. M is a positive integer, so m cannot be 0. So let's divide this equation by m. That is going to be m square minus 2m minus 3 is equal to 0. If you solve this quadratic equation, you will get m is equal to 3 or m is equal to minus 1. M is a positive integer, so m is equal to 3 is the correct answer over here. So which option we are going to mark? Option number 1, option number A we are going to mark over here. After this, there is some common data for question number 18 and 19. So let's read that common data. 5 horses, red, white, grey, black and spotted, participated in a race. As per the rules of the race, the person betting on the winning horse get 4 times the bet amount, and those betting on the horse which came in second get thrice the bet amount. Moreover, the bet amount is returned to those betting on the horse that came in third, and the rest lose the bet amount. Raju bets rupees 3000, 2000 and 1000 on red, white and black horses respectively, and ends up with no profit, no loss. Question number 18 is, which of the following cannot be true? So let's read these 5 statements, so we will come to know which kind of calculation we are supposed to do. First statement, at least 2 horses finished before spotted. Red finished last. There were 3 horses between black and spotted. Yes, so basically we need to find the various possibilities depending on the given data. The given data is what? Raju is having 3 bets. rupees 3000 on red, rupees 3000 on red, then rupees 2000 on white, and then rupees 1000 on black. Total investment by Raju is 6000, and there is no profit, no loss, means this 6000 becomes 6000. He do not lose, he do not gain. So we need to identify the various possibilities of the positions of these three horses. So let's have a look at it. If the horse comes first, for the first position the bet amount will get multiplied by 4. Then if the horse comes second, then the bet amount will get multiplied by 3. If the horse comes at third position, then the bet amount get returned. It means it is multiplied by 1. If the horse ends at position 4th or 5th, then they are not going to return any amount, means your bet amount will get multiplied by 0. It becomes 0. So we are going to invest these 6000 rupees and we are going to get 6000 rupees. That's it. So you need to check the various possibilities over here. So let's do some trial and error. We need to do some trial and error over here. So what we can do is the first possibility. Let's say first possibility we need to get total 6000 rupees by using these three bets. So the first is white is on 2000. So let's multiply this 2000 by 3. So let's say white horse comes at second position. So this 2000 will get multiplied by 3. And this becomes 6000, and the remaining two horse, that is red, comes fourth. So the amount will become 0, and the black will come fifth. The amount will become 0. So this is the first possibility. White comes second position, red is fourth, black is fifth, or vice versa. Black is fourth, red is fifth. This is the first possibility. Now the second possibility. So basically over here we cannot multiply 3000 by 4. Understand one thing. This 4 into 4, we cannot multiply 3000 by 4. It becomes 12,000. We cannot multiply 2000 by 4. Then it becomes 8000. We want to get 6000 rupees. So into 4 is possible only with 1000. So let's say black horse comes first position. So this 1000 will get multiplied by 4. Now we need 2000 rupees more. So let's say white horse comes third. So this 2000 will become 2000 into 1, 2000. And the remaining the remaining red horse, it comes either 4th or 5th. So it becomes 0. Red comes here or here. So it becomes 0. This is the second possibility. Is there any other possibility? Let's check to get total of 6000. Then what we can do now is 1000 into 3 we can do 3000, and 3000 we can do. Let's have a look at it. The third possibility is, let's say black comes at second position. So that 1000 will get multiplied by 3. So it becomes 3000. And let's say red comes at third position. So that 3000 will get multiplied by 1. So total is 3000 and 3000, 6000. Now the remaining is white. White comes either 4th or 5th. Over here also red comes either 4th or 5th. Over here white comes either 4th or 5th. It will become 0. So these are the three possibilities. Now is there any other possibility? Let's check. Is there any other possibility? Let's check now. If 1000 into 1 is 1000, and then into 3, now look at white multiplied by 3 is the only possibility. So basically white and red now cannot come on first and second position. So before we go, let's have a look at the options. Question number 18, let's have a look at options over here. Which of the following cannot be true? At least 2 horses finished before Spotted. Spotted is one of the horse. It may possible that, hold on, let me read statement 1 again. At least 2 horses finished before Spotted. It may possible that Spotted horse will come over here or Spotted horse will come over here. So the option A is very much possible. Option A can be true. Option B, red finished last. Over here red can come on 4th as well and 5th as well. So it may possible that red is going to finish last. Then statement number C, there were 3 horses between black and Spotted. Between black is over here, Spotted can be over here. So there are going to be 3 horses between black and Spotted. It is very much possible. Third statement. Statement number D, there were 3 horses between white and red. Over here white and red, there are 3 horses in between, not possible. Over here not possible. White and red over here also not possible. So option D cannot be true here. Option D cannot be true here. Let's check statement E as well. Gray came in second. Gray came in second. It is possible over here in the second case. So this is how we can solve question number 18. Now let's try question number 19 with the help of same calculation. So let me copy question number 19 over here. What I will do is I will delete this data here. This is question number 19. Question number 19. Suppose in addition it is known that gray came in 4th. Gray came in 4th. It means gray came in 4th. It means first case is not possible. Now over here gray came in 4th means red comes at 5th. Red comes at 5th. Okay. Over here also gray comes at 4th position means white comes at 5th. Now then which of the following statement cannot be true? Spotted came in first. It is very much possible here. Red finished last. It is possible over here. White came in second. Yes, white came in second is not possible. Let's check other statements as well. Black came in second. It is possible here. There was 1 horse between black and white. It is possible over here. So statement C cannot be true here. Now let's have a look at question number 20 and 21. F of x is equal to ax square plus bx plus c, where a, b, c are certain constants and a is not equal to 0. And it is known that f of 5 is equal to minus 3 into f of 2 and 3 is the one of the root. So we need to find the second root. So let's take the roots of the given quadratic equation. One of the root is 3. Second root, let's take it as k. So the given quadratic equation becomes m into x minus first root into x minus second root. So now we know that f of 5 is equal to minus 3 into f of 2. The value of f of 5 is how much? In this equation put x is equal to 5. You will get m into 5 minus 3 into 5 minus k is equal to minus 3 into m into 2 minus 3 into 2 minus k. So if you solve this further, this m and m will get cancelled out and we left with what? 10 minus 2k is equal to, this is going to be how much? 3 2s are 6. 6 minus 3k. So if we solve this further, you will get k is equal to minus 4. So minus 4 is going to be the another root over here. So the value of f of x becomes how much? M into x minus 3 is the first root into x minus second root is minus 4. X minus of minus 4 means x plus 4. This is nothing but ax square plus bx plus c. In the second question, we need to find the value of a plus b plus c, but as we don't know the value of m here, we can't find the value of a plus b plus c, so the answer becomes cannot be determined. After this, let's have a look at question number 22. The number of common terms in the two sequences. Let's have a look at it. The first sequence is 17, 21, 25. You can see that the difference between any two consecutive terms is 4, that is constant, so it is arithmetic progression. The value of d is equal to 4. Second series is also arithmetic progression. The terms are 16, 21, 26. The difference between any two consecutive terms over here is 5, so the value of d is equal to 5 here. So over here the common terms are also going to be in arithmetic progression. So what you need to do over here, you need to find the first term by using trial and error, which is 21 is the first term. And the value of d is equal to the LCM of d1 comma d2. This is d1, this is d2. LCM of 4 comma 5, that is equal to 20. So the first common term is 21, second common term is plus 20 41, then again plus 20 61, then 81 and so on. These are the common terms. The last common term is going to be 21 plus n minus 1 into d is 20. And this last common term should be less than or equal to 417, because the number which is more than 417 cannot be common to both series. So let's solve this inequality. This is going to be n minus 1 into 20 less than or equal to the subtraction is 396. So n minus 1 is less than or equal to 19.8. So n should be less than or equal to 20.8. So the maximum value that n can take over here is 20, because n has to be the natural number. So there are going to be 20 common terms in between these two series.